When talking about chemical bonds, you're going to hear the term ionic and covalent bonds brought up quite a bit. So it's important to know and be able to compare these two types of bonds. So if you look at this quick little cartoon image here of the two dogs, this kind of gives a quick summary of ionic and covalent bonds. Ionic is the transfer of electrons, in this case represented by bones. Covalent is going to be the sharing, and sometimes the equal and sometimes unequal sharing of electrons, in this case represented by the bones for the dogs. So on a more chemical note, the ionic bonds are typically formed when between metals and nonmetals. One atom donates electrons while the other atom accepts them. We can kind of see that here where this electron is being donated here, being transferred over. Then we get a partial positive, negative charge. Those are coming together to form ionic bonds. In contrast to that, covalent bonds typically form between nonmetals, and that's our atoms sharing electrons to achieve stability. Typically it's between two nonmetals. It could also be between a metalloid and a nonmetal as well for covalent bonds. Now a detailed comparison between the two ionic bonds, their bond strength is strong due to the electrostatic attraction between those oppositely charged ions. The electroconductivity, meaning these ionic bonds conduct electricity when dissolved in water or in a molten state. They typically have high boiling or melting points due to their strong ionic interactions. We also, when we compare this to covalent bonds, their bonds can be strong, but it depends on the number of shared electrons. They generally do not conduct electricity. They tend to be more of insulators. And their boiling and melting points tend to be low to moderate, depending on the molecular structure. Lastly here, just a couple examples of our ionic bonds would be sodium chloride or table salt, where we see that transfer of that electron forming a cation, a positive sodium ion, and an anion or negative chloride ion being brought together. And the covalent bonds would be water, which is sharing electrons between hydrogen and oxygen. If you want to dive into this in a little bit more detail, it would also be considered a polar covalent bond because those electrons aren't necessarily shared evenly, that oxygen's pulling those a little bit closer to that. So this gives you a good quick comparison so you understand the difference between the ionic and covalent bonds.